Hi, everybody. I hope you're having a great week. I'm going to talk a bit about what we've been learning this week about four different growth curves. So you don't have to write these in your notebook. You can just listen along. It's really no new material. I'm just trying to go over what we've already studied, maybe put some names on some of the things that we've talked about. But if you'd like, it's always helpful to write things down so you can look them over. Um, Kind of puts that information in a different part of your brain. If you want to, I'm gonna draw pictures of the four different curves that we've seen about population growth, and then write a few notes about each one. But like I said, if you're not in the mood to write these in your notebook and you want to just listen, then just do that. But this should reinforce the things that we've seen so far this week. The first kind of growth that we saw, we watched that we had that spreadsheet, um, and always at the bottom of these growth curves, we have time, and then we're always talking about population over here. And the first curve that we saw really wasn't a curve at all. It was just straight like this. We graphed those numbers on that first activity, and we call this, if you recall, this was linear growth, right? That means, right, that the rate does not change, right? As time goes on, the same number of individuals are added each week, each year, whatever that is. Um, the slope is a specific number. The rate does not change. This doesn't really happen in nature. We don't really see this kind of growth in nature. Um, this is more of a mathematical function. I suppose it's possible, but it just doesn't really happen that much. What's much more likely to occur, here's another graph, time at the bottom, population over here. What's much more likely to occur is this. What kind of growth is this? That was the second kind of growth that we saw on that first activity. This was called exponential growth, right? So as time goes on, you can see the rate increases and increases. The slope is very little here and the slope is very big here. So rate increases, right? As it turns out, all populations experience exponential growth. All populations experience exponential growth, at least in the beginning. Um, these numbers here, even though they're not increasing very much, this is still exponential. Um, at some point, though, we know that this can't go on and on, right? I mean, because look, this is just going to go straight up. We're going to start running out of stuff. So we need a third graph that shows something more realistic. So if all populations start exponentially, at some point, we know something's going to happen, and we're going to get like with the moose population. What happened to that moose population? What was likely happening here? So the moose population's on an island. It became so big, they must have run out of something. What did they run out of? They probably ran out of food. They ate all their food. So right here was that last bush or whatever that moose eat was destroyed. What happened to the moose population? Well, it just plummeted. went straight down, almost to zero. It might have gone down to zero, but apparently some moose survived. And then if the moose survived, a couple, the they lived on to reproduce. And since there were hardly any moose left, the plants came back until we had another curve like this going up until the same thing happens again. And then there's this die off. We call this a boom and bust, right? Here's the boom, and then here's the bust. And then it happens again, boom and bust. So let's write something down here. What happens though? Well, boom and bust means that there must have been some limiting factor. So exponential growth always happens, but it can't continue because there's some limiting factor present that stops the exponential growth, right? So in this case, probably it was, for example, not enough food, right? We're calling that a boom and bust cycle, and that's what happened to those moose on that moose on that Isle Royale. They just kept on doing the same thing. But we can draw one more graph because that's not the last one. We're going to draw one more graph. Again, we have our time down here, and then this is our population here. Always populations experience exponential growth, right, in the beginning. But that second time with the moose after 1950, there were some wolves, wolves came onto the island. And so the population never had a chance to go up here, right? What did the wolves start doing? The wolves started eating the moose right about here. So the moose never had a chance to overeat. Their population, instead of going like this, right, their population started going down because of moose, right? And so the wolves ate some of the moose, but because that happened, the population never had a boom and bust cycle. And so it might have gone up and down a little bit here and there, but it really stabilizes the population. This is an important concept. This is called logistic growth. Logistic growth, right? And that is exponential in the beginning, right? Exponential in the beginning, but then something in the environment keeps the population from growing exponentially, right? So in this case, it was predation. So the example would be predators. So here, right, something in the environment keeps the population from growing exponentially. This is exponential here, right? Exponential, right? And it would have continued. It would have continued if it weren't for the predators. So are predators, I think I spelled predators wrong, predators. Are predators good for moose? Well, I mean, wolves aren't good for individual moose. They eat individual moose. But for the moose population, it prevented the moose population from overeating its food source. So it is what it is. I would say that wolves are good for moose populations, maybe not good for individual moose. And there's a lot of things like this in nature that sort of kind of even things out. And this is where a more complex system with lots of different animals is actually more stable than a system with fewer animals. So a system with just moose wasn't very stable. We go through this boom and bust all the time. But if you add some animals, right, add some animals that eat the moose, and the population becomes more stable. And we're going to use this information about these curves, and you should recognize these curves when you see them and make sense out of some other situations on the last activity of the week. I hope you found that helpful. If you need any help with any of this, you don't understand something, please come and talk to me during my office hours. I'd love to see you. Just call and say hello. Some people just call up and say hello. I don't mind that at all. Talk to you soon.